Let's solve a quadratic inequality. When you're solving quadratic inequalities, you're trying to figure out where is your parabola above or below a certain y value. So in this one, if I were to consider that left-hand side as a parabola, I want to know where is it above 0. So maybe it looks something like this. So the areas where it's greater than 0 would be here and here. And those would be my two solutions for this inequality. But I need to first figure out where does it hit 0, and then from there we'll decide is it above or below 0 after that. So let's start by first figuring out where does this equal 0, and then we'll find the inequality from there. Now that I've factored, I set each factor equal to 0 and solve. So now I have found the two places where my equation equals 0. So these are going to be our two kind of boundary points, and we need to figure out what happens everywhere else. So we're going to have a zone on the left of our -4. We're going to have an area in between the two zeros, and then we're going to have an area after that 3 halves. And we need to figure out in each of those 3 intervals, is our graph above or below 0. Let me sketch it out so you can get a better idea of what we're talking about. Okay, so these are the two zeros that we found. What we need to figure out is your graph above the x-axis on the outsides of these zeros, or is your graph maybe facing downwards and it's above the x-axis in between those two zeros? Well, we do know that our leading coefficient is positive, so we know that our graph does face upward, so this is what it's going to have to look like. And those two outer edges, those two outer intervals, are going to be where our solutions are located. However, not always is it going to be this straightforward. So a technique that we often use is to use intervals. And I'm just going to plug in test points to figure out, are we above or below the x-axis in each of these 3 intervals? So I will pick a test point from each interval. I'll pick maybe -5 from that left interval, 0 from the middle, and then +2 from the right. And I plug them into my original inequality to see, do we get something that is positive or do we get something that's negative? So I'll start by testing -5. So we did get something that is positive, which means that this first interval is part of our solution, which is something that we were already expecting. Let's go ahead to the next interval and we'll test 0. Here we got something negative, so I can expect that that second interval is not part of our solution, as the y values are going to be below that x-axis. My last interval, I'll go ahead and plug in my +2. And we got something positive, so that third interval will also be part of our solution. Again, just like we expected. So there's a couple different ways to write your solution. My first is to write it using inequalities and saying that my x's could be numbers that are less than -5, or they could be numbers that are greater than 2. The other option is to use what we call interval notation, and that is to say that x's are going to be in a particular interval. So the lowest I can go is down to -infinity, up until I hit -5, and then I have to stop. But I do put a parentheses because we can't equal -5. We can't equal 0, and -5 is the point where we equal 0. So I put a parentheses saying you're not going to actually be able to use that -5. And then I pick back up at 2, and I go all the way up until infinity. Again, not actually using either of those points either. I put a u in between to show that we're uniting these two intervals, and this would be another way to write the solution to your inequality. So that's a quick example of solving a quadratic inequality. I hope that helped. Thanks for watching, and I'll see you next time. Bye.